Hello friends, welcome to Q.3. In this video, we shall be solving question number 1 to 3 of exercise 8.4 on trigonometry. So let's start. Now, I feel that this exercise is a pretty interesting exercise for what? For using the PBH concept. And we will use the PBH concept in this exercise immensely. Now when I say PBH, I am talking about all of these. So basically these two tables is what we'll be using immensely here. Okay. Now the question says, express the trigonometric ratios sin A, sec A and tan A in terms of cot A. So the very first thing that we can draw here is, we can draw a triangle so that we can find out all of these. So what I'm assuming here is, let us say this is angle A, this is angle C, let's say, angle D. This becomes my perpendicular, this is my base, and this is my hypotenuse. And we know that cot A is equal to base upon perpendicular. We know this. So now what we are supposed to do here is, we are supposed to express the trigonometric ratio sin A in terms of cot A, sec A in terms of cot A, tan A in terms of cot A. Okay, so let's start from the easiest. So the easiest here is, we know that tan A is perpendicular upon base, which can be written as 1 divided by B by P. And how much is the value of B by P? Cot A. So we got this. Now sec is basically what? Sec is the reciprocal of cos. So if I am able to find out sin A cos A, then we can always find out sec A in terms of cot A. Now we know that sin A is equal to perpendicular upon hypotenuse. Okay, so we know that for cot A we require B and P, and here we have an H and P. So all we need to do here is convert this H into P and B. So we are aware of the fact that H square is equal to P square plus B square from the Pythagoras theorem. So from here you will be able to say H is equal to under root of P square plus B square. Let's substitute the value from here. So can I write it like this? I can. Once you have done this, now we want what? Since we have to convert, we have to express sin A in terms of cot A, what we are expected to do here is, we are supposed to convert these ratios, and we have to convert this into B by P. So dividing the numerator and denominator by P. So when I divide the numerator by P, and when I divide the denominator by P. So when I divide the denominator by P and put it inside a square root, now we know that P has to be understood as under root of P square. So when you're dividing the numerator by P, it is just like you're dividing it by P, but the denominator, when you divide it by P, since you have to put it under a square root, you'll put it as P square. Once you have done this, you can rewrite this as 1 divided by, now P square by P square is 1. So from here you get the value. Because cot A is B by P. Last, you are supposed to find out the value of sec A. Now sec A we know is how much? This is hypotenuse upon base. So doing the same thing as you had done in terms of sine, this gives you a fair enough idea of how to go ahead now. You already have the base and you have to convert this. So you convert this into P and B. And then you do the same. You do what? You divide the numerator and the denominator by a P. So when you do this, this is the expression that you get. because you have divided both the numerator and the denominator by p. So p by p becomes equal to 1 as we had done here, and here you are dividing it by a p square. Once you have done this, now you will be able to say that this is under root of 1 plus cot square a. So tan a is equal to 1 divided by cot a, sin a is equal to 1 divided by under root of 1 plus cot square a. Okay, now once we establish this, let us see the expression that we have got for sec a. Is it correct or not? And why does this give me some feelers here? Because I know that 1 plus cot square c is equal to cosec square c. So have we done some mistake here? Let's find it out. We know now sec is the reciprocal for cos. So, and cos is based upon hypotenuse, right? So now when I take the reciprocal for base upon hypotenuse, we get what? Hypotenuse upon base. And then we substitute as we had done. But while we were solving this, we did a mistake. What is a mistake? Instead of a b, we placed a p here. So when you are solving a question, please ensure that you do not make a silly mistake. So now what will you do here? Now in this case, you will divide both the numerator and the denominator by a p. So when you do this, you get it as this is b by p, and you know that p when put under the square root becomes a p square. So now this expression can be written as like this. Right? So now can I get the value now? Let's see. So I hope this has been understood by you, and let's move to question number 2. So in question number 2, they are asking you to write down all other trigonometric ratios of angle A in terms of sec A. So we will do the same thing as we had done in the first question. The modus operandi remains the same. I mean, the way to approach remains the same. You will draw a triangle here. Now the angle A that I have taken in this case is an acute angle, though they have mentioned nothing here. So maybe in such kind of questions, it is not necessary to mention the type of the angle here. Okay, we'll see to this. So we know that once we have drawn the triangle here, angle A, angle D, angle C. So we know that angle A plus angle C is equal to 90 degrees. Angle D is equal to 90 degrees. This is perpendicular, this is base, and this is hypotenuse. Okay. Now sec A is the reciprocal for cos. Cos is base upon hypotenuse. So sec A becomes hypotenuse upon base. These are 4 things that we'll be requiring when we are solving this question. So you can make a note of this before you begin. So hypotenuse is equal to under root of p square plus b square, which comes from Pythagoras theorem. And p, or any expression, can be written as under root of p square, and b, base, can be written as under root of b square. So we will be requiring either all of these or most of these we will be requiring. Okay, so starting off with sin A. Sin A is perpendicular upon hypotenuse, and we have to express this in terms of sec A. Sec A uses base and hypotenuse. So in that case, I have to convert this p into b and h. So p in this case becomes what? So we'll have to realign this, and we will say that p is nothing but under root of h square minus b square. Once you get this, now you come to know that you may require this as well. Right? And just to be more emphatic here, you can just change this, or you can let it remain. If you know how to do it, you can let it remain like this, or you can just write down this Pythagoras theorem. From here, you can get the value of p square, which is h square minus b square, and the value of b is nothing but under root of p square. So which is what you get. Now dividing the numerator and denominator by h. So inside a square root means what? You should divide it by h square. So this comes out to be a 1, and you can write this as, this is 1 minus sec square a. This is something that you get from here. Now you know that cosec is the reciprocal for sine, so it becomes very easy for you to use the same expression with its reciprocal. Now coming down to cos a. Cos is the reciprocal for sec, so you can simply say this is nothing but 1 upon sec a. Now here you require what? You require a base, because sec a requires a base and a hypotenuse, but tan a uses p and b. So b you have to retain, and then you have to find out the value of p from here. So when you do this, you can use the same value of p. Now, can I say dividing? So now when you're solving this, we identify that here when we were dividing it by h, so this value is not, we were not supposed to find out b by h. We were supposed to find out what? We were supposed to find out h by b. So in that case, what will we do? We will divide both the numerator and the denominator by b, not by h. As discussed in the earlier question also, many a time what will happen is, in our hot pursuit of solving the question, we may tend to make mistakes. Making a mistake is not wrong, but once you have solved the question, you should have some time to revisit the question and see, have you made some mistake? Okay, so now in this case, what are we doing? We are supposed to find out h by b. So divide both the numerator and denominator by b. So in this case, when you have divided, so which is just like saying what? This is sec square a minus 1 divided by sec a. So when you are finding out the value of cosec, which is just the reciprocal for this, you will say this is nothing but sec a divided by sec square a minus 1 whole under root. Okay, coming back to tan a now. So we know that p is equal to under root of h square minus b square, and we need to get the value of h by b. So now I'll be attentive. So we are supposed to find out the value of h by b. In that case, you will divide both the numerator and denominator by b only. So when you divide the numerator and denominator by b, you get the denominator as 1 and the numerator so which is just like saying this is so let's see, do we already have this with us? Yes, this is the expression, this is the identity that we are talking about. So now in terms of cot, we know that cot is the reciprocal for tan. So this you can write it as, this is 1 divided by under root of sec square a minus 1. Right? I hope you have understood this question. Let's move on to question number 3. So question number 3 has been divided into two subparts. The first subpart says what? Evaluate sine square 63 degrees plus sine square 27 degrees divided by cos square 17 degrees plus cos square 73 degrees. Now I'm reminded of my first video on interesting facts on trigonometry. So I hope now you'll be able to understand why those interesting facts were done to solve questions like these. So had you known those interesting facts, it becomes very easy for you to attempt such kind of questions. Now what is the identity that we are going to use here? So we know that sine square a plus cos square a is equal to a 1, and at the same time we know that sine a can be written as cos c. So Now, can I say this is nothing but cos square c plus sine square, so keeping one of them as constant. So here I am keeping this as constant. Now I keep this as a constant, and then I variate this, and I know that if a plus c is equal to a 90 degrees, it is then only that I can use these trigonometric identities in the way in which I am maneuvering it. Okay, so now this is sine square a, cos a we know is sine c, so this I can write it like this. And last but not the least is I can variate both of them, wherein I know that sine a is cos c and cos a is sine c. So you will see in one case you are having sine square a, cos square a is equal to 1. Similarly, you can use cos square c plus sine square c is equal to 1, and these are two acute angles not equal to 90 degrees. Right? It is very obvious from this assumption. Okay, at the same time you can just change these values. So now in that case, if you are changing these, in that case cos remains the same. If you are changing these, sine remains the same. If you are keeping these as constant, then sine and cos they interchange. So using this logic from here, now is 63 degrees plus 27 degrees equal to a 90 degrees? Yes. So changing this but keeping this as a constant. This is nothing but 1. Using what? Using this. And from here you know that this plus this is equal to a 90 degrees. So you are variating this, keeping cos as constant. So this also can be used as a 1. So you get the answer as 1. See, it becomes so easy. Similarly, I know that sine 25 degrees and cos 65 degrees. Now we know that the sum of these, the sum of 25 and 65 degrees is equal to a 90 degrees. So in that case, it becomes relatively easier for you to convert this into any one of these. So for example, sine 25 degrees can be written as cos 65 degrees. So this can be written as, this is cos square 65 degrees. And at the same time, I know that sine 65 is cos 25. And we did a similar kind of a question. So now we know that this plus this is equal to a 90 degrees, keeping cos constant. So this can be written as 1. Now, if you feel that something very, very interesting and very informative and knowledgeable things have been discussed in this video, please do not forget to like, share and subscribe to our channel. If you have already done so, click on the bell icon and select all so that you receive regular updates from us. If you want us to do some specific videos on specific topics, please put it in the comment section so that we can do for you. Thank you so much. Until next we meet, goodbye.